Hey, why did I do that? Right, and then we have a round thing somewhere around here. Okay, so what we have now, so we draw our elements, right? So this is our element A, on top element B, right? Centroid relative to the elements, right? Then we have a 800. We have a 600. And then we have a 500. Okay. So the 800 will induce axial load, which we already have it already. So Py is equal to 800, which we have in our previous analysis. So this one is done. Then we realize that there's a moment in the x direction. All right. From here, we can see there's a moment in x. So let me move this drawing so I will not waste so much space. Right. So we know that there's a moment in z, sorry, x, and positive is going this way. So this will be equal to 600 multiplied by 8. Yeah, so 600 times 8 is equal to 4,800 pound-inch. And this is the direction. So if we are going to do, this is the direction, the compression, tensile, right? It's so convenient, right? You can now visualize the moment vector. Head of the moment vector is compression, tail and tensile. So everything is so straightforward now. So from here, if we do apply the formula where we have stress Y is equal to mx over Ixx multiplied by Z, right? So we know that element A will be equal to 0, element B will be equal to compression, right? Why element A is equal to because it's at the what? The centroid. Okay. So more or less we have sorted out everything. Okay. So let's consolidate what we have. All right. So we have Vx and Vz. Right. So Vx is equal to Vx is equal to 500 pounds. And we also have Vz, 600 pounds. We have our torque in the y direction. Right, so torque in y we calculated is equal to 720 pound-inch. And then we have an axial load in the y, which is 800 pounds. And then we also have a moment in the x, which is equal to 4,800 pound-inch. And then we have moment in the z, which we have calculated, is equal to 1360 pound-inch. 1360. So now we have to assemble everything again, okay? So let's do, what I like to do is deal with normal stress first, okay? Then deal with shear, because the shear sometimes can be really complicated. So let's deal with normal stresses first, okay? So I'm going to do both element A and B at the same time, okay? So we are going to concentrate on element A for now, right? So you can see element A, so stress in Y is equal to Py over A, right? I don't know yet, so this is M X over Ix multiplied by Y. Don't know yet. Mz over Izz multiplied by Y. Okay. So Py, we know will induce a tensile, right? So Py over here, what we have for Py is 800. Divide by pi r squared. So basically it's divided by pi because the radius is 1 squared. Okay. So now we look at mx. Okay. So moment about x, right? So we can see down here. So this is moment about x. So mx is going to induce a 0 because it's at element A. So this is plus by 0, right? Then mz for element A. So we look at mz, right? So this is mz for element A is in what? It's in tensile. So you check over here, element is tensile. So now you know it's positive. And you know mz is equal to 13600 divided by izz, which we have calculated earlier. So izz is equal to 0.785. The radius is 1. Okay, so this will be equal to 800 divided by shift pi plus by 13600 divided by 0.785 is equal to 17.579 positive times 10 to the power 3 psi. Okay, so 800 divided by shift pi plus by 13600 divided by 785, 17.579. Okay, so that is our one of our stress value. Okay, so this is for element A. So now let's do element B. Okay, so we again, I'm going to do on the side over here, element B. So stress Y is equal to Py over A. Don't know yet. Mx over Ixx multiplied by Y plus or minus Mz over Izz multiplied by X. Okay. So one thing for sure, the Py over A is the same. So 800 divided by pi 1 squared. Okay. So at element B is going to induce a compression. So minus, right? Minus by 4800. The distance is 1. The Ixx is 0.785. Okay. Moment about Z for element B. Okay, so we know that element B is equal to 0. Right? Moment about Z. Element B is at the centroid, is equal to 0. Right? So that's why I encourage you all to do the analysis. It makes your calculation so much simpler. Okay. So this is equal to 800 divided by shift pi minus by 4800 divided by 0.785 is equal to minus 5.86 times 10 to the power 3 psi. Okay, so let me do it again. So 800 pi minus 4800 divided by 0.785. Yep. Okay. Right. So the next one that I like to do is I'm going to do the torque. Okay. So I'm going to deal with the shear. Now the shear, right? If I'm going to draw, let's deal with torque in the y direction, which is at 7200. Okay. So if I were to draw now, if I were to sketch element A and B, okay. So the first thing I want you to do is to identify the torque direction. Okay, so you go over here. The torque is in what? In a clockwise, right? So the 600 multiplied by 12, right? So this is the torque. The torque is going to rotate in this direction. Okay. Why that direction is important? Because this is the shear that's going to be induced on the torque. You can see that, right? And the arrow is hopefully the same size because the magnitude is the same. Okay. Then I'm going to put in our element. So element A, element B, right? And then if I were to put our transformation where I'm looking now, that is why there are software to do this. Okay, but what if we don't have software? And the software to do this is very expensive. McMaster Gadget can calculate this by hand. Okay. So over here for element B, right, you can see the shear, the intersecting plane is Y, right? However, the shear is in X direction, right? You look at this arrow over here, it's more in the X direction. And for element A, the intersecting plane is still Y, but the shear is like in the vertical direction. This is horizontal direction. So is XZ, okay? But the formula to use to calculate this is the same, okay? So now we are going to declare, right, shear YX is equal to the torque, which is equal to what? The torque is equal to 7720. The radius is 1, and J is twice of I, which we have calculated, which is 1.57. And you have to take note of the direction, okay? So this is for, sorry, shear XY or shear YX for element B. Okay, so 7200 divided 1.57 is 4.586 times 10 to the power 3 psi. And the direction, you draw it this way. Okay, so 720 divided 1.57. So the shear YZ at point A, right, is also equal to the same value. psi, and then is going up. Okay, so those are our